Today we're going to learn about indirect measurement. Our foldable looks like this and just folds up into a cute little booklet. Okay, so indirect measurement allows us to use the properties of similar triangles to find measurements that are just too big to measure otherwise, like how tall a building is, or a roller coaster, or a tree, or something really tall that we couldn't just measure directly. All right, so let's see what this means. So to find the height of a tree, we could set up a proportion using the measurements that are given. So you can see we have this tree. We don't know how tall it is, so we're calling it X. And it's casting this shadow on the ground here. That's 43.5 inches. And then we have a person standing nearby, and that person is 64 inches tall, casting a 32-inch shadow. So when we say we're using similar triangles, what we mean is that this man and his shadow make a right triangle here, and then this tree and its shadow also make a right triangle, and they are similar triangles, both of them right triangles. So we're going to use this guide that's given to us here, where we put the tree height over the tree shadow, and that equals the man's height over the man's shadow. So the tree height is X, the tree's shadow is 43.5, the man's height is 64 inches, and the man's shadow is 32 inches. So if you remember, when we learned proportions way back in the beginning of the year, we solved this by doing cross products. So I'm going to do 32 times X equals 43.5 times 64. Whoops. You are allowed to use your calculator. So if I put 64 times 43.5 into my calculator, I get 2,784. And this becomes a one-step equation. So since X is being multiplied by 32, the opposite would be to divide both sides by 32. And 2,784 divided by 32 is 87. So that tree is 87 inches tall. All right, let's try another example. Here we have a basketball hoop. We do not know the height of this basketball hoop, but we do know that it casts a shadow of 9 feet. And then we have nearby a trophy that is 2 feet tall, casting a 1.5 foot shadow. So this time the proportion is not already set up for me. I have to do that myself. I know that a proportion is 2 equal fractions. And so we're just going to set them up the same way. So I'll do basketball hoop height over basketball hoop shadow. And then I'll make that equal to trophy height over trophy shadow. So I'm going to do height over shadow equals height over shadow. And just make sure you set them both up the same way. If you do height over shadow and then switch to shadow over height, you're going to get it wrong. So just be consistent. So we're going to do cross products again, where we multiply across. I have 1.5x equals 9 times 2. So 1.5x equals 18. I am allowed to use a calculator as long as I show my work. So if x is being multiplied by 1.5, the opposite is to divide by both sides by 1.5. And 18 divided by 1.5 is 12. So we can see the basketball hoop is 12 feet tall, a little taller than regulation. It's usually 10 feet tall. Alrighty, let's try the next example. In the next example, we have a telephone pole, and we don't know that height, but we do know the telephone pole is casting a shadow of 144 inches. And then there's a dog nearby casting an 18-inch shadow, and the dog is 2.5 feet tall. So before I fill in my proportion where I'm going to do height over shadow equals height over shadow, I want to note that the dog's height is given in feet. That's kind of a little bit tricky, huh? So let's change that 2.5 feet to inches. I can do that by multiplying by 12 to find that the dog is 30 inches tall. So now let's do height over shadow. Let's do the dog first to show you that it doesn't matter which order we put them in. I can put the dog first, or I can put the telephone pole first. But if I'm doing height over shadow, I have to do height over shadow for both of them. So let's do the dog's height of 30 inches over the dog's shadow of 18 inches equals the telephone pole height that we don't know over the telephone pole shadow that we do know. And then I'm going to do cross products. So 18 times x equals 30 times 144. And I'm going to do 30 times 144 in my calculator to get 4,320. Whoops, I left out a number there. 4,320. And since this is now a one-step equation, I'm going to divide both sides by 18 since x is being multiplied by 18. And I find that x equals 240 inches. We probably wouldn't state the height of a telephone pole in inches though, so if we wanted to change that into feet, we could divide by 12 to find that it is a 20-foot pole. All right, and the last example on our notes has this little map drawn out for us with two triangles. It says that these triangles are similar triangles. We want to know how far apart is the school and the market. So let's make a smaller highlighter here. Okay, we've got right angles here. So those two sides that make right angles are called the legs. The short side over here is going to correspond to the short side of the other triangle. The longer leg here will correspond to the longer leg in the other triangle. And then the hypotenuse, which is what we call the longest side of a right triangle in this one, corresponds to the hypotenuse in this one. So when I have two triangles or two shapes that are similar and they're not drawn in the same direction, I can either redraw them so they are facing the same direction or use highlighters to show my corresponding sides. Of course, it saves space if I use highlighters. So I'm going to set up my proportions and I can do like yellow side over yellow side equals blue side over blue side. And if I'm going to do the small measurement first, I need to do that in both ratios, both fractions. So I did like small yellow over big yellow equals small blue over big blue. I'm going to use my cross products and do 400 times x equals 360 times 200. So 400x equals 72,000. And then I'm going to divide both sides by 400. And I get that x is equal to 180 miles. That is the distance between the market and the school. Thanks for watching.